Hello there. My name is Alex Hunton. I am here to talk about odometry. This is presented by Ace Robotics Team 154430, and this is part of FTC competition for the 2020 Skystone. So, what is odometry? Odometry, simply put, is the use of motion sensors to perceive data about the robot. This data is then used to calculate the position of the robot relative to various game objects, the field itself, and more. It is a powerful tool used to make correct decisions in both automatic and tele-up mode of the competition. So, odometry is all about the idea of getting inputs and generating outputs on decisions that the robot wants to make itself. It's all about receiving an input from a mechanical device like an encoder or a sensor, and using mathematical principles that you learn in like a math class in your high school, and to construct and decode it into um, outputs that the robot can actually understand, like movement of servos or motors, and the speed at which that they'll go in order to have the robot accomplish the tasks that you want. So, for example, if you have the robot here at 0, 0 and you want to get to 1 to 1, then you can use your trigonometric functions to find out what one angle it should be at, and two, what the distance is, and then you can use some other basic mathematical principles to determine what speed that you want to place onto your motors in order to have it go forward. So odometry is all about that. It's the use of mechanical outputs to get and calculating in the programming to get mechanical outputs as well. So with that, that means that there's various devices that we can use in order to receive these inputs and get the things that we want. There's encoders, which will measure the direction, amount of rotations, and speed at the end of any rotating shaft. So this is all about getting the information of what has happened. Similar to maybe a graph showing that distance over time, this should give an indication of how many spins or how many rotations a motor has gone through given a certain time. Let's say after you knit the code or after you knit the robot's iteration, it will show you how much distance has been traveled. This can give good information in calculating where the robot is relative to its starting position. It's really helpful for decoding motors and getting to the point where you have inputs and finding it so that you can later on determine um, any kind of goals that you want to set for the robot. A gyroscope measures the change in direction travel in the robot. Once again, this is similar. This is a little more advanced than decoders, which will are primarily there for the motors and to attach to them to determine individual motors. A gyroscope will more give you an accurate measurement of the overall robot of where the gyroscope itself has moved, depending on first turning it on and traveling. And this is the same principles are aligned with encoders and encoders and gyroscope. It's just all about determining inputs in order to get an output. And then a camera, which is very useful in FTC, using various programs like OpenCV and visual processing libraries. You're able to determine maybe how far you are from a certain picture on the field, being as there's many of those, especially all around the field and on the sides of the field. And I know this year it's on the brackets and whatnot. And so this is really helpful for just overall determining how far you may be away from a certain coordinate. I know this year's field that each side has its own picture, and being able to know the distance between you and that picture can kind of give you a determination of one, where exactly the robot is, and maybe determine how far away are you from the center. So it's really helpful to have a camera on board, and I know as the phone itself can be used as a camera, and this is overall really helpful. So what's the point of it all? Um, you think about it, your own life and how you make decisions moving through it. Think about your own personal sensors, your touch, your feel, your hearing, your nose, your mouth. It's basic. Odometry is all about um, getting those sensors and the processing of your brain. So it's not really, you can't just hook eyes to something or give something a camera and expect it to think. Odometry is all about the processing and the logic behind determining what to do with sensors and various other things in order to once make a decision. So robots need to make decisions based on their own senses. Odometry takes those senses, we give the robot, and makes sense of it, if you will. And then there's a great, more specific examples from this YouTube channel, from this YouTube link by Georgia Tech. This gives you a great, more specific example. It doesn't give into the nitty gritties, but it will definitely give you more defined examples of how robots can be um, shaped and how sensors can be given and what kind of calculations you can actually do to determine um, location, angle, and various other things. Thank you for listening, and if you have any more questions, email or call us at acerobotics14430 at gmail.com, or we have a help number. Thank you so much, and have a good one.